Right, so for this function f of x, we've been asked to find the interval over which it is convex and the interval over which it is concave. It's cubic, so it's telling us it's going to have both sections in the curve. Now, from our definition, we know that if we have a concave function, looks like a cave, then because the gradient is decreasing, our second derivative, d2y over dx squared, is going to be less than or equal to 0. Remember, d2y over dx squared is the same thing as f double dash. And alternatively, if we have a convex function, concave, convex, now its gradient is increasing all the time. So d2y over dx squared, the second derivative, is going to be greater than or equal to 0. So let's have a look at our function and then we'll apply our definition. So f of x is equal to x cubed minus 3x squared plus x minus 2. If we find the gradient, by differentiating we get 3x squared minus 6x plus 1. If we differentiate the second time, f double dash, we get 6x minus 6. Now, for a concave function, always remember, I know you know this, but I'm just going to d2y over dx squared is the same thing as f double dash of x. I know you know that, but I'm just putting it there. Right, for a concave function, the second derivative it's got to be less than or equal to 0. So that means, or that implies, that 6x minus 6 is going to be less than or equal to 0. And then we solve. So 6x is less than or equal to 6, and x is going to be less than or equal to 1. Okay, so anything less than 1 is going to be concave. And for a convex function, the second derivative, d2y over dx squared, is going to be greater than or equal to 0. Okay, so that's our convex. Its gradient is increasing over that interval. So that means 6x minus 6 is going to be greater than or equal to 0. And we solve. 6x is greater than or equal to 6, and so x is greater than or equal to 1. And that's that then. Just trying to think how else you could write it. That's job done. So you could write this as, because it's coming from minus infinity to 1, and here you could write going from 1 to infinity, but there's no need. Happy enough with that and with that. Okay, good.